Okay, this is 8-9, example 2. This isn't one that has a try it with it, but I wanted to talk about it just for a second. So, okay, we're going to do that thing again where everything's frozen. Okay, all right, let's try it with this. So, as I've stated before, the formula for volume of a prism, so we're going to write volume of prism. I'm having technical difficulties today. Oh, for Pete's sake. There we go. The formula for volume of a prism is the area of the base times the height of the prism. The remote is right there by where you were eating your lunch. Okay. Just in case anybody needed to know that. Okay, the area of the base times the height of the prism. What's interesting about a prism is that the sides are always rectangles, and then the top and the bottom of the prism match each other. So in this case, they're both hexagons. Sometimes they're also rectangles, and then those look more like a shoebox, and that's fine. So when you see the formula written, whenever somebody's talking about the area of a base, they use a capital letter B. You don't have to, but that's typically what that means. And then the height of the prism, they use a lowercase h. So it's confusing because that looks like it says base times height, but it's not base times height. It's area of the base times the height. So in this case, the base is a hexagon. So rather than try to draw one, I made this little copy, except that I can't grab him now. Come on. Oh, there he started moving. Did you see that? Come on, little guy. Why won't you come out and play? Oh, just a second. All right, I finally got mad and hurled the entire thing out the window, but I think this is where we left off. Okay, so the base, we're going to talk about this base. So the base that we're dealing with in this figure is actually a hexagon. And I have a hexagon ready right over here. I'm not sure how to grab it and move it, and so I'm not gonna worry about it right now. Okay, so in this figure, this hexagon, regular hexagons are made up of 6 equilateral triangles. So we know that the edge of each triangle is 4 inches. So that's 4 all the way around. And the thing about equilateral triangles, or equiangular triangles, or whatever you want to call these, that means that the edges are all also 4. So in this triangle, it's 4 here, 4 here, and 4 here. The deal is, our problem is, in order to figure out the area of one of these triangles, we need to know the height of the triangle. And the height is not 4, right? So when we look back up here at the shape of this hexagon, notice that straight across the box from one edge to another edge is 7 inches. So if straight across this is 7 inches, then this portion would be halfway, and so that would be 3.5 inches. So let's, we could do a rainbow marker. So let's talk about the area of just one triangle. So this one triangle, the formula for area of a triangle is 1/2 times the base times the height. I'm going to use a lowercase b because it's different than this base, times the height of the triangle here, which is different than this height, right? Okay, which is why some people prefer to say 1/2 times length times width, and that's also okay. So 1/2 times, and then our two dimensions we want to use are 4 and 3.5. 4 times 3.5. That's a rad pen. It looked like it said rad pen. Oh, it says red. Disappointed. So 1/2 times 4 times 3.5 is 7. These are inches. And since this is an area measurement, it's 7 inches square. Okay, so now that we know that the area of the base is 7, now what we need to know is how high is this prism? And you know what? They don't tell us, do they? I'm not sure that they do. I know that the ball itself is 6, so we know that the height, let's write this down. Height must be greater than 6 inches. Otherwise, the ball's not going to fit. So we're not really sure what the height is, but we do know what the volume is. The volume is right here. The volume is 294. So what we're going to do, there's only one thing here we don't know, and that's height, and we should be able to solve it. I'm going to draw lines down my equal sign so that I keep the left side of the equation and the right side of the equation separate from each other. In this equation, if I want to get h alone, the way to get it alone is to do the opposite of this to both sides. So the opposite of multiplying h by 7 is dividing h by 7. And whatever you do to one side, you have to do to the other in order to keep these guys equal. So over here, the 7's cancel each other out. 7 divided by 7 is 1. So you're left with 1h. And 294 divided by 7, I don't know what it is. Wait, 42, I'll bet. I bet it's 42. 294 divided by 7. Boom! 42. 42 what? The height is 42 inches? Oh my gosh. You guys, you know what I'm doing wrong here, right? Remember down here when I found out that the area of one of these triangles was 7 inches? How many triangles are there? That's right, there's 6 triangles. And 7 times 6 is 42. So the actual area of the base is 42. Never fear, I can fix this. You guys are the best ever. Doop, 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 doop. All right. So the area of the base is 42. I want to get the h alone, so I divide both sides by 42. Divide by 42. And guess what? 294 divided by 42 is 7. So the ball itself is 6 inches wide. We know our shortest distance here to here is 7 inches. It's going to be even more corner to corner, so 7 inches. So it'll definitely be wide enough for the ball. The ball is 6 inches tall, and this is 7 inches tall. So yeah, it's going to fit. And once again, making mistakes is not a bad thing, it's a very good thing, and for the most part I promise to hopefully always not delete my mistakes, but to share them with you. And I hope that you share your mistakes with me too, because that is the very best way to learn. And the thing that I hope most of all is that a few of you were yelling at your screen while I was going through, Ms. Gatzman, there's 6 triangles! That's my dream. All right, that's it for this question. Took 10 minutes.